Okay, so now we're going to continue. We will buffer the parks to a quarter mile. Now we had the parks data and draw a quarter mile buffer around each park, and these buffers will encompass areas that are close to existing parks and are therefore out of consideration. So from the Los Angeles River geodatabase, we will drag the parks to the map. So parks is right here. I'm gonna close this out. We already have a buffer. Parks, drag it here. And then we will right click on it and zoom to layer there and move this aside and move this aside and organize a little bit. And we will turn off the Los Angeles River. So, Los Angeles River buffer. And then we can already see a lot of overlap between the existing parks. So, where's my river? Okay. A lot of overlapping, and we must still extend the exclusion zone a quarter mile further out on all sides of each park. So on the analysis toolbar, that we're gonna click the analysis and buffer again, and drag the parks layer for the contents pane into the input. And so I'm gonna drag this time. So release, and the other parts kind of just like autofill, except the default output feature class named parks buffer. And in the distance box, I'm gonna type to drop down list miles and 0.25 miles in the linear unit drop down list, and click the dissolve type drop down. So dissolve type, okay, no dissolve, and here I'm gonna say dissolve all output features into a single feature. Perfect. So this setting dissolves boundaries between overlapping park buffers. The dissolution of boundaries isn't strictly required, but it makes it a lot easier to interpret the result, which would otherwise be a dense tangle of lines. A side effect of dissolving the buffers is that the output will consist of one multi-part feature, essentially devoid of attributes. That is okay, because all of the need from this layer is its geometry. And I'm gonna check the setting against the figure and click run. So now everything is fine. Gonna run. When the tool is finished running, the parks buffer layer is added to the map, and the feature class is created analysis output. So we go to parks buffer, which is right here, and turn off the parks layer. Turn this layer off, and then change the transparency of the parks buffer layer to parks buffer layer. Go to appearance and gonna type 50, and how the contents pane, collect parks buffer layer and change the transparency using the sidebar appearance and effects group right here. So the portion of Los Angeles layer buffer not covered by the parks buffer layer represents the layer areas that are still under consideration. So the buffer, the layers are purple and tan in here, but mine is blue and then purple right here. So now we can think about what analysis we have accomplished so far. One layer, Los Angeles River buffer, contains all the area within a half mile of the river, and we want to exclude the parks buffer area from that area, but those areas are stored in a different layer. Essentially, we want to subtract one layer from another. So what we're going to do is erase park accessible areas. So the tool for doing this subtraction is named erase. So I don't use a lot of erase tool, but this tool is a member of the family of spatial overlay operation that helps make GIS such a powerful technology, unlike the buffer tool. And the erase tool is not available in the tools gallery, so we will find it using a search. So I'm gonna close it out and go back to analysis here and gonna say erase. So erase. There. So analysis tool. And here we have the erase, and click Erase Analysis tool and open this tool. And for the input feature parameter, we're going to click the Los Angeles buffer. So Los Angeles River buffer. I'm gonna just drag it here. No. And release. And for the erase feature parameter, click Parks buffer. Okay, and name the output feature class proximity zone. So you see it's already analysis here, analysis output geodatabase and proximity zone. Okay, and then we don't have to put any X or Y tolerance, and then I'm gonna click Run. So check the setting against the figure and click Run right here, and when the processing is finished, the proximity zone layer is added to the map, and we will close this geo processing pane. And in the contents pane, we will turn off all layers except this new one. So I'm gonna turn everything off. There. it's weird, I know. And this turn it off and symbolize the proximity zone in a medium blue, for example, Cretan blue, and this color will help the layer stand out against the base map. So I'm gonna right click on it, Cretan blue. There. Cretan blue. So we are left with a reduced portion of the original buffer zone. We search for a park. It is now confined to this shape. And now we're going to change the transparency of the proximity zone layer to 50. So the same way, appearance, and type 50 in the effects group, 50. Under the slider on the Appearance tab with the layer selected in the Contents pane, so we will zoom some holes in the proximity zoom layer. So we have some holes right here. So we can see that in the figure, the effect that the existing parks visible on the base map had on the creation of the proximity zone layer. So you can see the holes here and right here. So. And pan on the river and look a few more examples if we see some anomalies such as a hole with no parks, and consider that the topographic base map may not correspond exactly to the parks layer. We can turn the parks layer on and off the contents to see parks on and off. There. Yeah, somehow that have it. When we finish, we zoom to the proximity zoom layer and save the project. Now we will continue to apply demographic constraints, so that will be very interesting. So we have isolated areas that meet two of the requirements, distance to the river and a distance from parks. Still ahead are the tasks of factoring the neighborhood demographics, population density, income, and age, and evaluating parcels by size and total population served. We will deal with the demographics here. And within the proximity zone, we want to find areas that have the right demographic criteria. The problem is that the blue blob, if we can call that the blue blob, if we can call it that, it doesn't include those attributes. They are found only in the block groups feature class. What you want to do when it is make a feature class that has the spatial area of proximity zone and the attribute values of block groups. So this combination again calls for an overlay. So we subtract one layer from another, but overlay operations are typically more addictive than subtractive. So usually we want to find common ground between layers that have different attributes. The important attribute in proximity zone is its distance to the river. The important attributes in block groups are population density, age, and median income. So by overlaying these two layers, we will get all of these important attributes in a single layer. So the overlay will cause splitting of any block group features that lie partly inside and partly outside the proximity zone. What happens to the attribute value of these attributes? If a block group with 2,000 people is halfway in the proximity zone, should the output feature defined by the overlapping half get all 2,000 of those people or just 1,000? By default, attribute values are copied rather than apportioned. Apportioned in overlay operations, and copying can lead to anomalies in which large attribute values are assigned to small slivers of geometry. We have dealt with this problem ahead of time by using block groups, attribute values that are statistically homogenized and assumed to be uniform across the feature. It is also possible, however, to redistribute attribute values by area during geoprocessing. So overlay block groups on the proximity zone. We want to keep all the geometry of the proximity zone layer and only as much block groups geometry as is spatially coincide with the proximity zone. This type of overlay is called identity. It keeps all the geometry of layer A, the source layer, and only the coincident geometry of layer B, the target layer. So if necessary, we're going to start here, and now I'm going to add the block groups to the map from the project geodatabase. So block groups right here, add it here, and move the block groups layer under proximity. Oh my god, under proximity zone. Okay, drag it down there. So and now we move this under proximity zoom so that we can visually see the overlap of the two layers. So right here, because this is transparent. And now let's zoom out a little bit. Okay. And on the analysis tab, we will click tools and search for identity. So identity. Oopsies. Okay, identity. So now we have identity. Open here, and for input, I'm gonna do click proximity zones and identity features. For identity features will be block groups. And change the output feature class name to proximity zone, and then underscore instead of identity, it will be demographics. And then check the setting against the figure and click run. So don't keep all attributes for sure. So when the tool is finished running, so double check it again. For input feature, we will have a proximity zone. Identity features will be block groups, and output feature class will be proximity zone underscore demographics, and attribute to join all attributes, and XY tolerance. Leave it and keep a relationship. Everything is here and gonna run. So when the tool is finished running, the proximity zone demographics layer is added to the map. A corresponding feature class is created in the analysis output geodatabase. So everything is here, there. So I'm gonna uncheck everything. I'm gonna zoom to layer. There. Oh, it has the 50% transparency for the. So zoom to the proximity zone demographics layer and turn off all other layers. So which I did in the contents pane except for the base map. That we see in the figure is a fractured version of the original proximity zone, and proximity zone underscore demographics has the geometry of block groups clipped to the boundaries of proximity zone. As we will see, it has the attributes of both input layers. So we examine the attributes. So looking at the attributes of both the input and output layer will help you understand that we have accomplished by the overlaying them using the identity tool. Now we open the proximity which is right here, proximity zone layer attribute table, and not this one. So we open this one. I'm gonna right click on it, open attribute table, and then the proximity zone layer consists of a single record, its name. So single record, we have a name, and then buffer distance attributes are inherited from the Los Angeles River layer. And we open the attribute table of the block groups layer and scroll across the attribute. And I'm gonna right click on it, open attribute table, and I don't have a cross because I have a huge screen. And this layer has 6,000. Which one is block groups layer? So block groups layer, open attribute table. So this one 6,417 records. It has the attributes we specify and created here previously. So open the attribute table of the proximity zone demographic layer, which is right here. So we drag the proximity zone demographic table by its title bar, and I'm gonna put down below here. There. So and I release so we can put them at the same time. So resize the window so we can see both block groups on the top and proximity zone demographics on the bottom. And then the proximity zone demographics table has 206. 206 table, the polygons. It has all the attributes of both inputs, proximity zone, and block groups, plus 2 ID fields that trace the features back to the input feature with which they are spatially coincide. And we're going to zoom in to the western end of proximity zone demographics layer, a map scale of so I'm gonna resize a little bit so I can see them at the same time. Okay, I'm gonna 24. So where do I go? Groups layer. One to 24, around here. Okay, so turn on the map tab, the selection group, and click the select, and drag the drag to draw a small box inside the feature indicated in the figure to select all features intersecting the draw box. So I might have to change the color. So I'm gonna change this color to okay. Click apply. Go back, close it out. Is this appearance 50%? Yeah. Blocks group layer. Okay. And then I turn on this block groups layer on the map tab in the selection. I click the selection tool. So go back to map selection. Okay, go back to map selection, which is right here, and drag to draw a small box inside indicated in a figure. So like this one. Okay. Like this one then. Okay, a small box inside the feature indicated in the figure to select all feature intersecting the draw box. Okay. Alright, we can see the map, and in the table the 2 features are selected. So let's see. I need to do is like this. Oh, that's a lot. Okay. There. So, well, I have to hit Shift. So drag to draw a small box inside the feature, indicated here because this feature is linked. So now I'm gonna do is we can see that in the map in the table there are two features are selected, one in proximity zone demographic, which is right here, the other is in block groups. So under layer underneath, which I had switched, okay, but that's fine. And click the Show Select Records button at the bottom of each. So now we're gonna compare a little bit. So, and we scroll horizontally across the two tables that we can see all the demographic fields. I don't have to. So now total population. So total population is right here, and over 18, median house income, square miles, except the square miles is right here. Top density, top under 18, and percent under 18, and the shape and the area. So all the block group values have been copied to the spatially corresponding features in the proximity zone demographics layer. And this distribution of values is what you want. These cut up block groups, some are cut up, some are intact, are the neighborhoods that we will query for suitable demographics. Note the importance of analyzing attributes such as density and percentage rather than raw numbers, and the top under 18 value of these selected block groups is 194. We would reasonably expect this value to be smaller in the proximity zone demographics feature because it doesn't include the whole block group. But because the attribute values are copied, it is the same. It is fair to assume, however, that the percent under 18 value would remain the same even when the block group is cut into smaller pieces. And this assumption is not the case, however, for the total pop attribute. And we might consider apportioning this value on the basis of the percentage of the area that was cut. The analysis will not rely on apportioning because we will be using the more detailed census block units to derive the park's excess population, as opposed to the block groups that we just used for the other demographic variables. So that we will have to talk about the apportioning attribute values right now, and then we close everything, turn off the blocks, and zoom to the approximate demographic layer. Okay, so now we're going to see make feature layer. So apportioning attribute values, splitting feature geometry has implications for attribute values. So in census blocks, it is census block groups is split by a buffer in an overlay operation, resulting in two output features. So by default, ArcGIS Pro copies the attribute values of the input feature to both output features. So this is okay for population density, which is already a ratio. So the value applies to the parts as well as the whole is not okay for total population count value because it doubles the population here. So example 2, we want to count the population inside the buffer, which covers part of the 3 block groups. A reasonable approach is to analyze the percentage of each block group's area that falls inside the buffer and assign the same percentage to its population value. So in this case, so we have a 1% of block group once area is inside the buffer, so it is contribution to the buffer population should be 1% of 1,755. Likewise, of block group 2 on the far right, 21% of 4,445, and block group 3 in the middle, 38% of 6,722. So the examples are variations of the same problem, which can be solved with a tool named Make Feature Layer. So this to make a layer from a feature class, essentially the same thing that happens automatically when we add a data to ArcGIS Pro. It has very useful parameter, however, a ratio policy checkbox for each attribute in the input feature class. When the drill process a layer made with this tool, the ratio policy is applied to any split feature, dividing their attribute values according to area. So so I'm gonna show you from here. That I'm gonna do is oh, it doesn't showing here apportioning. It's not in network. So I would say make feature layer. So make a feature layer, which is right here, and I didn't have the map, so it tells you that create a feature there. So unless we want to run it, so then I'm gonna run it real quick, and we will see the difference. So go back here. Alright, so I'm gonna close everything out and then deselect it. Go back to map and declare. So go back to analysis and tools. Make a feature class. Make feature layer. Make feature layer. So which is this one, and input feature that I'm gonna say block groups. And and then I can check this ratio for is the population CY. And I'm gonna say everything and run it. And let's see, it's attribute table. And 111, yeah, it's the same. And I'm gonna open attribute table as well. So I'm gonna put side by side because, oh, where did it go? That's fine. Oh, no. Okay. So the same field, let's see, under 18, every 1, 2, population over 18, household 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Object shaped total population over 18. And then median, okay, density under 18, percent under 18. Well, we should be fine. Ratio. So the example variation, same problem, which can be solved with the name feature layer tool. Make a feature layer tool. And then let's see. Object ID 1 and 2. Make a feature layer is run on the block groups feature class. Subsequent overlay operations give desired results. The final step to get total population of the buffer area will be used dissolve tool with statistic field. So here I check that. Okay, let's move on and see what we can use from this layer, okay? And we will select areas by demographic attributes. So the proximity zone demographics layer now contains the demographic attributes of interest. So population density, the percentage of children, and median house income. We want to consider areas only if they meet the household for the 3 values. So population density, greater area or equal to 8,500 people. 8,500 people per square mile, and the percentage of children greater than or equal to 22%, and median household income less or equal to $50,000. So we will use an attribute query to select features that satisfy these conditions. So on the map tab in the selection group, we still do select by attribute. Close everything out. So select by attribute. So I'm gonna dock this. So it's just really weird. Close this out. Close this out, and then select by attribute. Yeah, it's in a map. So you double click on it and then you dock it, just like Word document. So select by attribute. So then I have select by attribute. At the top of the select layer by attribute tool, we will click the layer drop down arrow and click proximity zone demographics. So name layer. So I'm gonna go down to click proximity and zone and demographics, and select the drop down menu defaults to be selected layer in the contents pane, so the correct layer may be ready to be selected. And make sure the selection types is set to new selection, and add a class. Yep, add a class. Oh, not this one. So so I have population density. I will make it as greater and equal to. So I'm add a number. So add the number 8,500 and click add. So and then add the class button again and create another class. So it will be add a class, and so it will be % under 18. % under 18 is greater and equal to, is greater than or equal to, we will put 22 here, add the class. So click the add button again and create another class, and household meet. So and yeah, it's and household. Okay. Median household income. Median house income is less than or equal to, so it will be 50,000 and click add. So I have 3 clauses here. So if the clause is getting too long to read in hindered, hover over and we will see the entire thing. So alright, combining the queries in a single statement is more efficient than making a series of selection and sub-selections. The AND operator ensures that the features will be selected only by passing all the tests. So now we can see the SQL. It's very easy. Population greater and equal to a 50, and this greater and equal to 22, and this is, so you just use and. So instead of typing this, now we can do selecting if you don't have a strong SQL query. So that close the geoprocessing pane when the selection runs successfully and the resulting puzzles are highlighted on the map. So now I'm gonna just keep moving on. Okay. So that I can just get the code. Alright. The figure shows the feature that satisfies the query, and there are not many. Gonna validate and invalidate it for us. So the figure shows the features that satisfy the query. There are not that many, and most of them lie towards the end of the proximity zone. So we open the gonna run first, and then open the proximity zone demographics attribute table and click show selected records button, and then confirm that we will have 27. So I'm gonna demographics, open attribute table, so we should have a 27 selected. Perfect. So there are 27 records selected, and review the values of demographic fields to confirm that they meet the park's criteria, and close the table but keep the records selected. So that what we're gonna do is, of course, we will copy features. We did this many times. Now we're going to create a new feature class from the selected features. So we will save these selected features to a new feature class. Previously, here we used the copy features tool from the tool list for this purpose. We will use that same tool but use a more convenient method to get to it. So we confirm that the puzzles are still selected and then right-click Proximity Zone Demographics in the Contents pane and click Data Export Features. So I'm gonna right-click on here and go to Data and Export Features. So Export Features, and this command opens the copy features tool with the input feature parameter already filled out. We will change the output feature class to good zones. So good zones, check the setting against the figure and click run. So I'm gonna click run, and after the tool is finished running, the new good zones layer is added to the map, and a new feature class is added to the analysis output geodatabase. So which is right here, good zones is right here. So I'm gonna zoom to layer, and I want to uncheck all these so I can know what is this layer. Wow, cool, not a lot. So I'm gonna zoom to layer, and we can close this out. And those are the layer that it's good for us, good zones. And turn off all layers except the new good zones layer and the base map. On the map tab in the select group, and we will clear button selection and go back here. We can clear and zoom to full extent, save the project. Okay, I'm gonna save it. And we will move on to select suitable puzzles. It will be exciting. So we have narrowed the focus on to a layer named good zones. So we have a good zones, and having covered the demographic criteria, we will turn the attention to the parcels. Thanks to the work previously, we have a data set consisting of all and only vacant puzzles. From this data set, we will select the puzzles that lie within good zones. And from that selection, we will further select puzzles that are 1/4 acre or larger. That selection will comprise the set of candidate park sites. Then we will do further analysis to compare the sites by total population served and their distance to the river. So the first part, we're going to select select vacant puzzle within good zones. We will select the puzzle using a spatial query. So then, if necessary, I'm not gonna start a new map. I'm gonna close everything out, and I'm going to add the puzzle, the vacant puzzle that we have. Vacant puzzle. Those are the vacant puzzle, and feature class to the map from the project geodatabase. So on the map tab, we will do select by location. So I'm gonna do select by location, and input setting will be vacant puzzles for sure, and confirm relationship drop down to intersect, and select feature parameter to good zones, selecting features, good zones, and leave the search distance box blanks. And then confirm that the selection type is to new selection. Yep, new selection. And puzzles will be selected if they lie partially or entirely within good zones. Some puzzles may across good zones boundaries because of how the zones are clipped. Should you include puzzles that straddle good zones, yes, we straddle good zones, and then there was no wrong or right answer. So by choosing the intersect spatial relationship method, we are going with a generous interpretation. We will select a puzzle if any part of it lies within a good zone, because we want to maximize the candidate pool. If we want it to be restrictive, the puzzle must be entirely within a good zone, and we would choose a method such as within. So compare the two in here. We have vacant puzzle and intersect and good zones. So we don't have to do anything else, and we will do the run, and gonna run. So open, then after done running, then I'm right click on it, open attribute table. So then we will have we should have, okay, so our puzzle should, vacant puzzle shouldn't be this one. I think I should have the vacant puzzle should be the vacant puzzle dissolve, because I think I did a wrong one. So let's see, attribute table 14. Yeah, that's the correct one. And alright, and the dissolve one was the correct one. I already added, I don't have to add it again. And select by location. Yeah, select by location, select by location. Select by location, and we can dissolve, intersect, and good zones, and leave everything. Okay, run it again, and then we should have, okay, right click on it, and we should have 55 out of 14,269 puzzles selected. So sorry, I have the dissolve one. Okay, and then we select subset of puzzles that are 1/4 acre or larger. So of the 55 selected puzzles, we want to keep only those that are at least 1/4 acre. We will select the subset using an attribute query on the acres field using the features that are already selected on the basis of the spatial query created in the last section. So here we have a selected by attribute button above the table. In the select layer by attribute tool, use the drop down menu to change the selection type to select subset from the current selection. This setting restricts the scope of the query to records that are already selected. I'm going to select by attribute. So already select this, select subset. Okay, I'm select attribute. So now I have the dissolve, and then I have the dissolve, then I have to run something. Vacant puzzle dissolve, which is good. Select subset. So I'm gonna change select subset from the current selection, and add a clause. It will be acres is greater and equal to, acres is greater and equal to 0.025, and add a clause. I'm gonna run, so we should have 6 out of, perfect. Okay. So that the of 55 selected puzzles, we want to keep only those that are at least 1/4 acre. So we will select the subset using the attribute query on the acres field using the features that are already selected. So on the basis of the spatial query created in the in here. So on the map tab, we did select by attribute button above the table, and here we did was query. I'll change the selection type to select subset from the current selection, which is important. And this setting restricts the scope of the query to records that are already selected. So we add the cross acres 0.25 acres, and we did run the tool in the attribute table. So now we can see it's only 6 out of 14,269. So, and the 6 puzzles meets all the condition. And at this scale, it is hard to see the selected puzzles on the map. We will take a closer look later. And now I'm gonna in the right-click vacant puzzle and click selection, zoom to selection. So I'm gonna close this up, and which is right here. So right click on here. Actually, it's in good zones. Is it in good zones? Vacant puzzle. Okay, vacant puzzle. Vacant puzzle. I'm gonna say selection, zoom to selection. All right. And then I'm gonna export the selected features. So the same way, it's not that difficult to do it. So, and I'm gonna do is that these 6 puzzles are the critical ones we want. They represent the culmination of the process, and we want to save them as feature class. Again, we will use the convenient export data method. So right click on here and go to data export features. So then and then for the name, I'm gonna just change it into 6 sites. Click run, and then we will close everything out. I'm gonna check all these there, and finally I can zoom to layer, so to know where it is. I'm gonna zoom out. I cannot see them. Are they too tiny? How come I cannot see them? Oh, they are very tiny. Oh my god. Oh my god. So there, they are there. So if I say zoom to layer, I cannot see them until until I'm zooming. Okay, they're just very tiny. Okay. So now we're gonna zoom in and take a close look at the 6 sites against base map imagery. And on the map tab, we will change it to gonna go back to base map, do imagery. So if I put imagery, it will be difficult to see. Yeah, there. So and we will remove the vacant. Okay, I'm gonna remove all these. Remove and then remove. Turn off all layers except 6 sites and imagery. So the 6 site polygons may still be difficult to see with the current scale and symbology for sure. And in the contents pane, we will open the symbology pane for the 6 sites layer by clicking the color patch below the layer name. And in the symbology pane, we will switch property view of necessary, and then we will fill the color to no color and outline. Set the fill and outline. So I'm gonna do is center apple, no color, and outline is median apple, and then the outline will be 2. Click apply. So choose the close the symbology pane for sure. Okay, and then open the attribute table for the 6 sites layer and resize the table so that the map is large and 6 rows are visible. So I'm gonna open the attribute table again, and since it's just 6, I'm gonna drag it down and up a little bit so I can see the 6 of them. The map is zoomed to one of the candidates' parcel, and although a portion of the parcel is being used as a parking lot. So there, yeah, parking lot, and I see parking lot here. The parcel is adjacent to a quiet street to the west and could be a good park. So, yep. And then in the drop down menu, we're gonna do, we still have a lot to do. So, and we will continue until we see everything here. Okay. Alright, so we're gonna do is in the drop down scale menu below the map, we will change the map scale to 1 to, oh my god, then I don't think I can see everything. Oh, just see 1 and some part here. Yeah. Gonna change it again. Okay, so change the map scale to 1 to 24,000 if necessary. Pan south to see the river. And in the contents pane, I don't see that thingy. In the contents pane, we will turn on the proximity zone. Proximity zone demographic, or proximity zone, which is right here. Yeah. And optionally turn and now I'm optionally turn on the parks layer, and if necessary symbolize with a shade of green, which is fine. So the view confirms that the site is near the outer range of the proximity. Near or outer, let's see. Where is the others? Gonna zoom to. Okay, there are two here. It's a little different, okay, but that's fine. So the view confirms that the site is near the outer edge of the proximity zone, and even more interesting is that the site has two other parks in the immediate vicinity that are both closer to the river. So I need to turn the river on. Not river buffer. I'm gonna get my river. No, not river buffer. I want the river, Los Angeles River. So put it on top. There. So gonna change it into just blue. Gallery. Just waterway. Waterline. Okay. There. I have my waterline turned on. That is why human interpretation of analysis results is so important. We considered proximity to existing parks, but it didn't occur to us that a park might be more than a quarter mile from a candidate's site and yet closer to the river. It doesn't invalidate the candidates, but it is something to think about. So gonna turn the parks. Oh, parks is here, so I didn't turn the parks on, so I'm gonna turn it off. Okay, and then the table, select the first record, right click the gray square and to the first record and zoom to. So which I already gonna do it again. Yeah. And which is about 1 to 1,000. Oh, for me it's a little scale a little closer. It's 500 instead of 5,000. So these two sites are closer to the river. So I'm gonna zoom out a little bit. So these two sites are closer to the river. Okay, let's see the river. River is right here. Yeah. Where's my river? Turn it on. Yeah, river. It's close to the river. Which is ideal. Notice a couple of the other things. First, the river bottom is natural here, which could make this site more scenic than others. The analysis doesn't take aesthetic consideration into account, but the views, sounds, and smells of parks affect the people who use it. On the other hand, that's very interesting to talk about the smell and the sound, the view, and smell. Okay. On the other hand, the site is also close to a freeway. This location has an aesthetic impact and probably a health impact as well. Should kids be exposed to all that car and trucks exhaust? And we will investigate the remaining site. So zoom to the remaining site and investigate them, and zoom and pan to see the relationship of the river. Turn off the other map layer on and off. Make observation that add contents to the analysis. So we can see the other one. So let's look at the second one, and I'm gonna zoom to. Alright, zoom to. So which is this one, and this one I'm gonna zoom to. Well, this one is a little crazy. It's close to, but it's not huge enough. Okay, and then river and a bike path. I didn't see the bike path. Well, it could be a bike path. Let's see. But now it's still parking lot. Okay. Okay, and then zoom to the other one. Alright, this one, this side is close to the river on a corner parcel. Alright. River is here, corner parcel, and this one is a long one. Yeah, this one is one has the bike path. Yeah. Alright. And this one is adjacent to a new adjacent to which one? Okay, this one I already look at, and should be, let's see if it's this one. Okay, I guess it's this one then. It's adjacent to a new Metrolink stop. Metrolink stop, I don't know. Metrolink stop, I need to go to Los Angeles and look again. Metrolink stop. So when we finish, we click clear button and move any selection in the table. So clear. There. And turn off all layer except 6 sites and the base map. So okay, I don't need this one. Alright, and then at this point, 2 items remain from the list of analysis criteria. We want a new park to serve the maximum number of people, and we want it to be as close to the river as possible. That's very interesting. Okay, then we know that all the sites are within a ½ mile of the river, but knowing the exact distance from each site would be a useful metric to help decision makers prioritize the sites. So we could use the measure tool to do that, of course, but we would face the same problem of repetitively writing the result to a table. Also, we might not be sure of making the shortest possible measurement. The near tool will make these calculations of the for us automatically. So on the Analysis tab in the Tools gallery, we will open Near tool. So I'm gonna Tools and Near tool. So did I type Near tool? Okay, right here, Near tool. Okay, so input here we will have 6 sites, and near feature we will have Los Angeles River, and then set the near feature parameter to Los Angeles River. Note that we can add multiple layers to the list of near features. Typically, the tool is used to disclose which feature in one or more layers it is closest to a feature of interest. So in this case, we want only one distance measurement. So using the drop-down menu, we will change the method from planar to geodetic. There. And this method gives you the most accurate distance regardless planar to geodetic, regardless of the map projection. So for more complicated data sets with more features, processing using this method may take longer because of the more complex geodetic distance calculations. But again, in this case, we want only one distance. So know that unlike most of the other tools we have used in here, the Near tool doesn't have an output feature class parameter. The Near tool does not create a new feature class. Instead, it will add a couple of fields to the 6 sites table. So then we would just check the setting and against the figure and click run. So before, 6 sites is right here already, and then we will just run and we will see a new field should be added here. Perfect. Okay. If necessary, then we open the 6 sites layer attribute table. The near distance field stored the distance in feet in which site to the river. This distance unit is dependent on the coordinate system, because our coordinate system uses feet as the linear unit. So the distance units are in feet. So sort the attribute table by near distance, so which is right here, in descending order to see how the sites rank in terms of proximity to the river. And we will add block centroids to the map and visualize the analysis. Okay. To do that, we're going to do is we must find the population within a ¼ mile of each potential park site. The basic approach for counting the block centroid around each park and summing their populations was introduced already and sketched in the analysis plan at the beginning of here. So we can do is using the spatial join tool. We might think of a spatial join as a spatial query plus a table join. So attributes from one table are joined to another on the basis of a spatial relationship between layers rather than possessions of a common attribute. So now we can get a visual sense of what we will accomplish with the spatial join by examining the population data within a quarter mile of a park site. And we will zoom in one of the site, change the scale to 10,000 to 1 versus 10,000 using the drop-down menu here. So 10,000. And then add a block group centroid from the map from the project geodatabase. Group centroid, block centroid projects. Okay, all right. And then the map is here. We add it here. So within the imagery-based map, we can clearly see the blocks that the point centroid represent. Open the block centroid attribute. Attribute table and find the population 2010 attribute. Alright, which is right here, population 2010. Excuse me. And this is the attribute we will use to find the population within a quarter mile. Now we're going to turn off all layer, including the imagery-based map, except block centroid and 6 sites. So everything off. And then we can see something here. On the map tab in the inquiry group, we will click the measure tool. So go back to map and then measure tool. So then click the measure tool, confirm that measure distance is selected by clicking the drop down arrow in the button. So where's my measure tool? Okay, option. I'm gonna change the option distance units. And I'm gonna do miles, and I don't want feet and miles. Okay. So on the button, change the distance units mile by clicking option from the measure pane in the upper left corner of the map and click the center of the site right here. Okay, center of the site, and then pointer to measure out. So 2.5 miles, perfect. So double click to stop measuring. Okay, so then we can see our river is still here. Yeah, it's within 2.5 miles. And in the next session, we will use the population 10 field value and sum the value within this quarter mile radius as a simple means of determining how many people are within easy working distance of the park. We will change the active measure tool back to explore by clicking the here, explore tool and the navigation. And now we're going to determine population around the park site. We will do that in the coming session, and once that we will add the demographic attribute to 6 sites access population. So we did a lot and we almost finished here, and the only thing was that we have to talk about geoprocessing tools and the analysis. We use a lot of tools like we copy the feature and we cut and we do buffer and spatial join. We didn't do spatial join yet. And I think we did erase tool and manipulate the relationship. It's the relationship between points and polygon and how they intersect, whether it's containing it, and the population we will use next and how far the distance, and it's complex and you have to sort it out, the relationship. So alright, we will see each other soon.